Hello, algebra students. Mr. Lawrence here. And tonight's video is going to talk about the converse of the Pythagorean theorem. You learned in class today that a squared plus b squared equals c squared when you have a right triangle, that if you square the legs of the triangle and add them together, it's equal to the square of the third side. It only works for right triangles. But somebody came along a little bit later and said, hey, I wonder what happens when we have different kinds of triangles. You know, we have right, we also have acute triangles. No, Gotham, that does not mean it's a triangle that gets a lot of dates. Okay, an acute triangle is a triangle where all the angles measure less than 90 degrees, all three angles. Okay, this happens to be an equilateral triangle, which is also acute because it would be 60, 60, and 60 degrees. Okay. We also have obtuse triangles where one of the angles is more than 90 degrees. Now, please don't ever say that two of the angles or all the angles are more than 90. How many degrees are in their triangle? Well, if you don't know, you should be ashamed of yourself being in algebra. But take a square or a rectangle. And a square or rectangle has four 90-degree angles, right? It is actually made up of 360 total degrees. And that's actually true for parallelograms, trapezoids, they all. If it's got four sides, it's got 360 degrees. Well, isn't a triangle half of a quadrilateral? And so therefore, if there's 360 degrees in the total shape, then in half the shape, there must be 180 degrees, because that's half of 360, right? So 180 degrees. So a triangle has 180 degrees in it. So therefore you couldn't have a triangle with two 90-degree angles, or two angles more than 90 degrees, because 90 plus 90 would be 180. The other angle would have to be 0 or a negative, which isn't possible. All right, so let's see what happens in an acute situation. And not all acute triangles are equilateral. It's just the most recognizable one, so I chose to use it. Let's attempt to use the Pythagorean theorem on it and see what happens. Of course, those little marks mean that all three sides have the same measurement, right? And so I'm going to go 5 squared plus 5 squared. And then over here in C's position, I'm going to put a 5 squared. Why? Because all three sides are 5. Okay, if I go 25 plus 25, this would be 25. And isn't it logical that the left-hand side is going to be greater than? In other words, a squared plus b squared is going to be greater than c squared. And this will become 50, right? 50 is greater than 25. That's true for all acute triangles. If I give you the sides, three sides of a triangle, you should be able to tell me if it's a right triangle, because a squared plus b squared will equal c squared. You should be able to tell me if it's an acute triangle, because if it is an acute triangle, then, hold on a second, my music stopped, then a squared plus b squared will be greater than c squared for all acute triangles. Okay? Now, you can probably guess what's going to happen in the obtuse situation, but let's test it out. Now, by the way, don't ever get confused about c. C should always be the longest side. Okay, so I'm going to go 12 squared plus 20 squared, and then I'll have 27 squared over here. Now, by the way, I hope you picked up in class, if I didn't mention it, you know, this would be the largest angle, this would be obtuse angle, and notice the longest side is across from the largest angle. Okay, that's the converse is also true. The smallest side is across from the smallest angle. All right, now with the analogy you have, it's not possible to figure out the measurements of these angles. If you get into trigonometry, you'll be able to do things, law of sines, law of cosines, things like that. Okay, but right now you don't know enough. And you might do it in geometry too a little bit. Okay, so anyway, get back to this. 12 squared is gross, 144, plus 400, and so that's going to give me 544. 27 squared, I think I just figured out, ooh, is that 729? Let me see, 27, I love exercising my mind. That's going to be 9, I'm going to carry the 4. Okay, I got 14, and 14 is 28, and 4 is 32. So now I'm carrying the 3. 4, 2 times 2 is 4, plus 3, yeah, it is 729. And look at that, a squared plus b squared was less than c squared. And that will be the same for all obtuse triangles. So now that you've got your three, let's test them out. Remember, if a squared plus b squared equals c squared, then we have a right triangle. Okay, if a squared plus b squared is greater than c squared, then it's an acute triangle. Okay. And then if a squared plus b squared is less than c squared, then it's an obtuse triangle. Okay, very good. So, hold on one second. Okay, so I've given measurements of 4 different triangles A, B, C, D, and we're going to figure out, without ever seeing the triangles, whether they're acute, obtuse, or right. And we're just going to use the Pythagorean theorem or form of it. Now remember, the largest number is always going to be my C number. So I've got C right there. Okay, on B, this one will be side C, the 16 will be side C, and the 68. Okay, that's always the most important thing. So I'm going to go 6 squared plus 7 squared, and then we have 9 squared. And that's going to be 36 plus 49, 81. And let me add those together. It looks like I'm going to get 85. And 85 is greater than 81. Therefore, this is an acute triangle. See how simple this is? Okay, we're going to go 5 squared plus 8 squared. And we're going to have 12 squared over here. 12 squared is gross. And then I'll have 25 plus 64, which is going to be 89. 144. 89 is less than 144, and that is going to make it an obtuse triangle. Okay, now I've got 8 squared plus 8 squared and 16 squared. Uh-oh, hold the bus, hold the bus. You should have learned in class. This can't be a triangle because the two smaller sides, 8 plus 8, have to be greater than the third side. This is not a triangle. You cannot draw an 8 by 8 by 16 triangle. It is not possible. Okay, if you think about it, if I live 16 miles from Edwards Middle School, I don't live that far away, but if I did, okay, from Edwards Middle School in a straight line, 16 miles, right? The shortest distance would be a line right there. If I go out of my way to get to Edwards, I stop off somewhere to pick up some milk or something, I don't know, some popcorn for an algebra party, stop off at the store. If I go out of my way, then come back, haven't I traveled a greater distance than just the 16 miles? Therefore, this side A and this side B added together must be greater than the third side. Has to be. So this is not a triangle. Not a triangle. It's not possible. Okay, this one here, I've got 32 squared plus 60 squared and 68 squared. So I'm going to square 32. When I was younger, I could have done that in my head. I guess I'm just slowing down. That's going to be 2, carry the 1, 9, 10, 24, I believe. 1024. Okay, 60 squared will be 3,600. Yeah, I like that. Now 68, can't do that one in my head, but that's okay. I can do it pretty quick on paper. All right, 8 times 8 is 64. Okay, 48 is 96. 102, I'm going to carry the 10, 36, 46, 24, I believe. 46, 24. Ooh, I'm liking this because I made it up ahead of time. And sure enough, 1,024 plus 3,600 is 4,624, and they are equal. And this is a right triangle. Yes, it is. All right, there you go. That's the converse of the Pythagorean theorem. Very powerful tool. Mr. Lawrence, signing off. Have a good night, everybody.